We left off looking at the parsing issues. Okay, so we need to deal with parsing function calls, handling multi-argument functions. I warmed it up and then I crashed, so we'll see what's up there. Right, so we moved variable expression. We reorganized a bit around variable expression so it became part of the expressions. I'm not sure I'm seeing. Maybe just move them on. We'll see. The test, okay, still starting up. Let's see. Oh, I just moved variable up, I guess. No real change. We also moved the lambdas in, so all these are part of parsing an expression. And let's see here. We made definition more explicit. It was using a default printer before. That only really helps us for debugging, so that's probably why we never saw it. Took out the parentheses. I think the tests didn't change too much. Okay, there's definition, so we made that work. And a couple more. Description again. Took out quotes. Function call tests. Well, this one may be the one. Oh, that's quotes too. Yeah. Well, if it ever starts, we'll find out. Well, the test succeeded, but I see a red bar over there somewhere. Okay, so function x equals x. Yeah, okay, so this is definitely expression equals expression. But, I don't think that's the right place to start. I think where we want to start instead is more of a function call situation. And that's, this is definition. So I'm going to take this test out. Now we still have the other tests around definition. Yeah, if it's well, this is more of an evaluation thing, but we had the ones for testing if definition has the right as string and so on. So I think that's the only failing test. It should be a lot faster to run that. Although, yeah. Okay, so let's commit this. We've got make definition dot as string. It's not really a, well, make that print nicer. And then I guess some minor refactorings to reorder methods we saw. Okay. I think, and this is where sleeping helps. I think we want to test function evaluation first. So, and even just the parsing of it would be something. So let's try test function call. Well, maybe this is this a parser test? Yeah, so we want to get the right expression coming out. Now, I've got questions on what Elm is doing for things, but let's see. So we're going to check successful. check success. Okay. I see it right there. All right, we put something in, we get something out. So this is going to be a function call. And then let's see the definition. Is that ours? Yes. Takes a closure. Huh. Well, it's not quite up to snuff yet, but we'll go, because right now it assumes there's only one argument. The closure is the function, which can be a named thing or a lambda expression. The argument, I didn't even know we supported one argument for anything yet, but we probably we did some experiments in evaluation. That's what it was. So we did test this case with one argument. Excuse me. All right. So function call closure. Interesting. Is it always a closure? Well, it probably is. We'll have to see how that goes. Okay, where did my parse go? There we go. All right, so I'm going to say, let's start with function x, function of 3. Okay, and when is function evaluated? That's the question. So let me go to Elm-REPL again. Oh, interesting. Okay. If I say function equals lambda x goes to x, and I say function of 3, I should get 3. But if I change it, lambda x goes to x plus 1, function of 3, I get 4. Okay, so what that's kind of telling me is I'm redefining this function and the same expression comes up with different values. I called function of 3 both times. So when I go to evaluate it, I need to, I guess I may have a name. The function may be a name, in which case I should look it up in my environment. Okay. Whoa, don't do that. Let's copy that. No. 2 control Ds is not recommended. All right. So function call, I think we need to allow another possibility. I guess this should be able to be a variable, like a function. And his argument should be an integer value, 3 elm type dot number. I do get tired of typing that elm type dot number. That's another thing on my mind. Okay, but can't convert variable to closure. Let's override this, or let's do something like this. Well, this I think is kind of a different thing. Maybe I'm tempted to call it closure function call. Let me rename this. The only place we use the other one is that test we just wrote. So if we rename this closure function call, okay, and let's go back to our test. This I think is going to be named function call. Okay, it's a thing that does not exist. Okay, let me back out a little more. I don't know, this, when you don't know where you're going, you end up doing these little probes. Function call tests. Okay, we'll rename this. Rename to closure function call tests, because everything in there is a closure function call. So closure function call works with lambda expressions. Function call works with variables. Named function call. Okay, this should all pass. It's just a rename in a commented out test. All right, so I'm going to commit this even with the test, because we're going to work on the test next. I'm being slightly lazy. Okay, so refactor, rename function call to closure function call. Okay, now this one, uncomment. All right, check successful parse named function call. So I think, let's see, let me get, do we still have the to do? No. Let's get this thing open. Parse function calls. I guess we also need to parse function definitions. Oh, that's the next story. Okay, parse function calls. So to do that, we need to create a named function. What do I even call it? Named function call. Okay. Now to frame this thing out, well, and again, I don't know. I'm going to use the test to drive stuff, but it's got so many layers. I think we're going to tackle the layers, a little closer in. Okay, but this definitely needs a named function call class to work. It's a Swift file. I was hoping rebooting would deal with this. Sorry for the flashing. The name is named function call. I'm surprised this works, but it seems to. Okay, class named function call is an expression that comes with obligations. Back to our test. Okay, it's going to take a variable. Well, what's it going to take? I guess I'm struggling. Is it a variable or is it an expression? Because maybe we can fold these things together. Like, how do you evaluate a function call? Well, if it's a variable, you got to look up its value and substitute that in. Excuse me. But anyway, we'll say it's a variable for now, and then later we'll see if we can fold it. And I think it's got... integer value, that seems fine for starters. We'll just start with one argument. Okay, so we needed a init that takes a variable of type variable and an expression type expression. And the type of this thing, wow. We're going to call it unknown for now. Okay. All right, what else we got? Takes a variable. Okay, this might build and it should fail. It might have more stuff we have to put in. Okay, expression print not equal to variable. Well, it's funny. I would think this would be named function call. Oh yeah, that's fine. So what's happening is you pass an fn3, it thinks, oh, I got a variable reference, which it is. I mean, the variable is really going to be stored here. Okay. So well, that certainly tells us we don't have as string defined. All right. So I'm going to push this test. I'm just going to comment it or block it. All right. Now let's create named function calls tests. Interpreter tests. New file. Named function call tests. Like, I don't know what's going on with this. Rebooting Xcode didn't fix it. Rebooting the computer didn't fix it. So it's not a good thing. All right. This should be similar to, you know, probably function call. I don't see a test for that. Well, similar enough. I mean, we need a test as string. We'll create I'm just going to say generically expression equals named function. We'll give it variable function and an argument integer value 3 comma elm type dot number. Okay, and we want to say expression.asString should be named function call of function and 3. Okay, I think that's correct. All right, and we'll just grab one of these. Oh, whoops. Yeah, kind of whatever. I just need to get I need an asString method. In here. All right, that also means I got to start saving my variables. So let variable of variable, let expression of expression, and then self.var equals variable self.expr equals expr. Okay, and this is named function call. Well, probably should be description. Did we see that test fail? I don't think we did. Oh, we did. Yes, we did. Yeah. Okay. Named function call variable of function not equal. Okay, I guess if they're just going to print their name like that, that's fine. We're just printing the expression. Okay, we will take that. I guess it affects our test. Okay. Named function call variable of function comma 3 is not equal to a variable. Have I got too many parentheses here? Okay, it's taking me more tries on my test than it is on my code. All right. Let's see. So named function call knows its description. All right. The other test we know we really want is an equality test, and let's take the closure one. Probably has it, I hope. Test equality. Yeah. Test equality. So we're going to equal. Well, this will be named function call. And the integer value 17 is okay. Closure. We just want a variable. Well, I guess I had that one. Okay. I'm not going to worry about symbol table. This one, 1A, 1B should be the same because they're going to have all the same stuff. And then we're just checking the second one. Let's make both variations. And let's make a 2B. Let's use variable other. integer value, and we'll take the integer value the same. So we're sort of testing each clause independently. All right, this is expert 2a. And again, this is a nice pattern from Jim Shore about if you want to test equality, define two things that are equal, that, because they have the same values, and then define things that are unequal. And the way I do it, I usually try and vary each argument. I don't always sweat it for whatever reason, but so in this case, the variable is the same, the integer value is different, the variable is different, the integer value is the same. So we can assert not equal on those two. And this is more for value types, things where you're testing they're equal if the values inside are equal. And I think, again, for the most part, I don't know that we need it for the interpreter side. I think this is really I would think it's really for the benefit of our tests, so we can check that something comes back and is the right thing. And we expect this test to fail. Maybe not every branch, but at least some. Okay. So it failed the first one. Variable it is not equal to variable it 17. All right. Let's see. And here. Okay, so in this case, we're trying to be equal to named function call. And we're going to look at self.variable equals other.variable. And self.expression equals other.expression. And we don't have three fields. Okay. Yeah. Should pass. Okay, good. All right, so we added EQ test to named function call. Whoops, what's going on? Try that again. That's better. Okay. I don't know, my disk drive's going like there's things happening, so I don't know. Maybe it's just a little slowed off on something else. All right. So I think that gets us started with the named function call. Let's just compare. It's got as string, it's got EQ, and evaluate we're not doing yet. So that sounds pretty good. All right. So I think we're back to our parser test. We'll uncomment it one more time. It should still fail. Probably the same failure, that it's a variable and not the function call expression that we expected. Okay. Function call variable is not equal to variable. All right. This is probably a good time for a break. So let's take a couple minutes and we'll come back and see if we can get things parsing. There's a little overlap here with the variable being there. Because if you have variable x equals 3, you evaluate just x, that should come back as a variable and be evaluated in the context or whatever. So we'll have to sort that out. All right, so 2 minutes. Hi, welcome back. All right, so we have this thing failing for more or less the right reason. And I guess what we're expecting is if you have a series of expressions, if it's just one expression and it comes back with a name, then it's probably just a variable. If you have multiple expressions with a name, we expect that variable is we expect the variable is a function and you can call it with the function. All right, so I'm tempted to try this REPL again. Okay, so if I have function, well, if I have function n equals n, we'll do it. We don't support this version yet, the definition like that, but we will eventually. Okay, and if I do function of 3, I get 3. All right, if I do 3 of function, I should get an error, right? Okay, too many arguments, right? That's an interesting error because it tells us that it really was trying to treat 3 as a function. So we always assume the first expression is a value, and if it's simple, it can be evaluated, but the other stuff has to be passed to it as a function. Now, a simple value doesn't have any arguments, so there's no harm. If I do 3 function, should be the same, yeah. Okay, value is not a function, but was given an argument. Function's the argument. All right. Now we're kind of to the point of parsing then. So let's get back to the parser. We can close some of these. But we really want to see the parser. Okay, so now well, I'm not convinced variable expression's in the right place, but all right, so now what happens is integers expression. Oh, this is expression. We've got a top level up here. All right, so if it's an int, a float, an uppercase name, left parenthesis, a lambda, reserved if, could be a lowercase name too, I think. If it's any of those things, well, if it's any of these things, it's an expression. Now in here, lowercase name is legitimate in an expression, so I'm a little puzzled there. Well, we don't have operators, so again, there's probably no way to make a multi-argument thing that would show this, but oh yeah, you got lowercase name, return a variable. That's an overlap. Well, it's an overlap that tells me this is, oh no, this is variable expression. Okay. Oh, this is our equals thing. Yeah. Okay. I got there eventually. It sort of builds in the variable. If it's a lowercase name is token and the next token is not an equals, then it's just a variable. That's true enough. But I think we're going to do something that covers all these cases. So I think what we're looking for is, well, I think what we're looking for is expressions. And when I say expressions, it means, well, I'll write it like this: expression plus one or more expressions. All right. And we're going to, we're introducing that to pass this test. So what's expression's going to do? Well, it's certainly going to parse one expression. Okay, we know the token is already starting out ready to be an expression. And if we call expression, it will evaluate expression and return it, which seems like a good thing. Okay, now nobody's using this yet, so we should call it up here. Expressions. All right, so I'm trying to take these little tiny steps. Still going to fail for the exact same reason, though. No way around that right now. Okay. Same one failing, right? Let's make sure. Function call failing. Same reason, not equal to variable. Okay, we're doing this. All right. So expressions. Now, I'm going to try and fold in this definition stuff a little bit. So if I have expression followed by if, which could be a variable, let's take this stuff. Okay, so if an expression is, after you finish parsing expression, it leaves the next we'll make it keep it for now. Okay, if you parse an expression and you see an equals next, you skip over that token, you match the expression on the right hand side, which really will be expressions, but we're not there yet. Maybe I don't want to do this here. Okay, let's find another way. So I want to keep expressions not doing it while it's got an equal. Okay. So let's do this for now. Okay. That should also be okay. We're calling expressions. Same test fails. Okay. So I want to make expressions be a list of one or more. Okay. So the way we do a while loop here, or the way we loop one or more, we've got one. Let's add the more. Okay. While, okay, and this is where okay. I have all these thoughts and ways of doing things, and it's like if I babbled them all out, I'm not sure anything would make sense. But one thing I'm thinking of is figuring out if the next thing is an expression is kind of it's kind of a pain right now. So we have these possible start tokens. We need them here because if you're in the start tokens, we want to do this again. And then, hey, look, these look very similar. Token int, float, lowercase name, blah, blah, blah. Okay, so what I'm going to do, it's like my day's labor today is introduce this test, comment it out, go do something else, comment it, uncomment it, try again, fails for the same reason. Okay, but what I'd like to do is I would like to give expression. I would like expression to know the characters. I don't know, maybe I'm overloading too much, but I would like something, let's say it that way. I would like some entity to know, to be able to tell me if this character is in this list, I want to do something. Now, I don't know if that's expression. Let's pull it out like that. Let's make a constant up here. And this is a set. Do we just paren braces? Okay. Is that my syntax? Okay. Consecutive statements must be separated. Oh, do I do set of? Argument type any expected to be constrained. Set of tokens. Does not conform to hashable. Okay. Let's. I'm sorry. Let's just Swift set example. Make sure I'm on the right track here. Set equals, and it didn't compute that. Did I not try the simple braces? Okay. Check if string present contains. That does sound like it needs a hash. Okay. Let's just try this. Whoops. Did they have to say set? Oh yeah, okay. And then it sort of infers some stuff. Okay, but I think we still need to make them hashable. Generic set strut requires token conform to hashable. Okay, let's go to token. Now I think it may generate a sufficient thing for that. We'll do a build. Type of expression. Yeah, okay. No. Oh. All right, seems like that. Oh. Argument type any. Expected to be an instance of a constrained insert immutable code set. Yeah, no, I'm not going to do that. Argument type any. Expected to be an instance of a class or class constrained type. I think this is telling me I can't make sets of enums. Is that what it really is coming down to? Raw value, recursive, we're not that. Find set. If I can't put them in sets, that really, ugh. Okay. We'll take a different way. Okay. We will define a helper function, I guess. Functions possible expression. You give it a token. Expression start. You give it a token of type token. And it returns a Boolean. I keep bumping up into limitations of these enums that kind of do everything. All right, I guess we're going to do this. EOF return false. Well, that's everything's going to return false. Possible starts. Yes, it's also a lowercase name. How about can start expression? Okay. Now, I want to change this so it's token and I got to take these out, and this lowercase name is going to be a problem. Okay. Well, let's take that out too. If token let's refactor. In other words, if it equals to lowercase name, we're going to return variable expression, else if it can start an expression, it's going to return expressions. Oh man. All right, let's see what we got for Swift. Swift switch statement. Does it let me put conditions in the front nowadays? I can't remember. If guard switch case pattern 1. And it's not going to like what I'm doing there. Okay. Is anything going to just work here? All right. If token equals lowercase name, cannot convert string arrow token to expected argument type token. Well, I can do it the other way. I can put it in here. I just don't know if it's I don't know if this is a good direction. So the way I'm doing this with the cases is pretty old school way, I guess. I was hoping I could do them with sets and then just go a next step, turn it into sets of maps from token to function and just let it go off that, and kind of a more modern approach to doing this rather than switch. But I think this as an alternative. So now I'm saying if it's a specific one, use the function we have already. If it's otherwise, if it can start an expression, then let's do expressions. So I think this is a refactoring. One test should fail. I think I will comment it out again if I haven't already. Okay, I have. No test should fail. They should run. Okay, there we go. And I lost my border here. Weird. Okay. All right. So we slightly pull out a method to decide if a token can start an expression. And I think that's a refactoring. It's a little sloppy, but should be. All right. Our expressions are really just one still, but that's okay. Right. So what I was hoping to do, something like expressions or definition. All right. So let's make expressions return let's make it return a list of expressions. No, we have to return a single expression argument, I think, to make the tree work. But what we want is, if it's one expression, we just want to return whatever that is. And if it's more than one, we want to return something that wraps it. Okay, so, and actually we need to decide about that equal sign at some point, but let's get the list of expressions. We might have to introduce something that just represents that function call. As long as there's no definition, it's okay, right? So let's compute them, and then all right, so now we can do while can start expression with the token. We can call append on our result. Append expression. All right. So let's see. So what we're saying is, you start off parsing an expression while you can still parse more expressions, even after they chewed up all the stuff in the first expression. If the next thing is an expression, then we should go ahead and append an expression to our list. And in the end, right now, we're returning results of 0. Okay, so this is, I probably should turn that test back on. Right. Okay, so now, if this case happens, all right, let's get back here. Where's my X? Okay. So now what I expect to get back is a function call with the variable function and the value. Okay. Actually, this, I think, should be an array of expressions. So let's make that happen. Okay, so we're going to treat the first one special and then just return the rest. Now, named function call doesn't do that. Okay. Let's make this expression array. And I guess we'll change this name to expressions. And this one, and the type here, most match. Okay. There should be some, yeah, some people are complaining. Well, let's let inner expressions equal well, I think I'm in the zone of that's not going to work, is it? Expressions. All right. Some tests should be failing. I don't know. I'm driving backwards again. Okay, this thing expects an array. Now the string it expects is this. Another array. Okay. Cannot convert value type integer to expected type expression. That sounds misplaced. Run tests. And I don't know. I don't think I have the braces in there yet, so I haven't dealt with them. Good. Okay. Function call failed. Is that the only one? Where's my one failing test? That's not what I expected. Name function call tests. Well, maybe it is what we expect. It appears to have called each one's description and put them in brackets for us. Okay. Yeah, that's kind of plausible. Okay, so function call parser tests. All right, another X. Now you might call this driving from a high level test. You might call it stacking because we kind of get stuck in the various levels. It's nice to me to have this high level test because in the end, like this is the thing we want to happen, at least to get this thing parsed. And, we got to drive a lot of details, but those details have to add up to doing this. And I think having this test here keeps us a little grounded in that. So I do appreciate it for that, but, it does make for a lot of back and forth. Okay. All right, so back to parser. Now this fails because we don't stick the right stuff in there on our parser. All right. So we just return results of 0, which is a variable. Why do you say succeeded? I guess the build succeeded, but the test certainly didn't. Name function call not equal to variable. All right. If right, parser. All right, that's testing. All right, now what we want, if we have a bunch of these, we want to take, well, if the count, we know the count's at least, well, what do we know? Could it be 1? Yes, it could be 1 because an integer value would just return 1 expression if we just had 3 there. If we had X, we're going to go down a different path. But right, so I think, well, we don't have the error cases in place yet, so I think what we can say is named function call result 0 result dot rest. What do you call it? Rest result dot drop first. That gives us some other thing. Gives us a slice. I don't really want a slice if I can avoid it. I thought there was a first and a rest. Well, remove first might. Oh no, it's. Converting a subsequence to a sequence. I don't remember the right. Drop first. I don't know if it'll take this, if it'll map it back for me. Okay. Well, this expects a variable. We haven't enforced this, but I'm gonna hard cast it for now. So I better put in my to-do. We better do some error checking on named function call. Okay. Back to parser tests and parser. All right, so we're forcing this. Apparently this is okay with reconstructing my array. And I don't know, we could pass. No, can't even build. Oh, cannot convert subsequence to expression. Okay. Convert array slice to array. I might just put in brackets maybe. Drop first gives an array slice. Or wrap it with array. Okay. Fine. Now I feel like I'm doing shortcuts and more than I like, admittedly. I mean, our test case does give it a variable, but come on, you know, that might not be what's there. But my hope is this passes. I think we have the pieces now. No, it blows up. Result sub-0. Okay, let's see what that is. Result sub-0 is an if expression. Oh, it's not even the right test that's blowing up. Well, maybe I have to do the semantics. If result.count is 0, 1. If it's 1, return result 0. Otherwise, we're going to assume it's a function call because it's got more than one result. And I think that's the case for us. Let's see. All right, so we'll run tests again. It's going to fail. It's got to fail for the right reason. I only want the one test to be involved. Okay. Which test is this? Check failed parse, check if without else. What happens? Signal abort. Cannot cast value error expression to Wilm error variable. All right. I had hoped to put this off. So this is what I talked about when I say if you're parsing, it's pretty straightforward and simple. That's this part here. You know, we want multiple expressions in a row. We just pull one, and then while we can get more, we get them. This stuff is getting into the semantics. Like, what do we interpret this as? Well, in this case, it's a simple result. In this case, it's something else. But the thing it's not answering is what happens if this thing is an error that comes back. Well, we didn't take that into account, and each one of these could be an error. So I'm going to. Well, we're good for another break. So let's take a break, 2-minute break. We'll come back and we're going to figure out some way to make it so that the existing tests pass, and hopefully the new test passes too. But we may have to do all the error checking and stuff here, because what happened here, somebody came back with an error expression. So could not cast this to variable. So somehow we got a multiple. Yeah. So I think in this particular case, if true then 3, it says you don't have an else. That's an error. Okay. And it says, okay, return the error. And it leaves it ready to look at the 2 and says, oh, it looks like another expression. And now we have error and function call. Okay. And it's like, ooh, that's not good. All right. So I kind of know what's causing it, but we'll see what we can do when we get back. So 2-minute break, and hope to see you then. Hi, welcome back. All right. So hopefully you're seeing what I'm saying, that we actually have 2 expressions here, a failed if statement followed by a 2. And, according to our parser, parse the if statement, then look for another expression. What I think we're going to have to do, or at least a way out, if the count is 1, that's fine. Else, if result sub 0 is, it will be a real thing, is error expression, then we're going to do something else, which is return it. Okay, and I'll keep these separate just to kind of keep the cases separate for now, but at some point we'll probably fold this in a little bit. Okay, so if it's an error expression, return it. Now we got the result coming back. All right, I think more tests will pass. What deep commitment, right? I'm hoping everybody passes, but okay. Who's one failing? Okay, is it the one we're working on? That's not so bad. All right. Test. Function call. Okay, so what happened to you is not equal to variable of function. So function 3, named function call, variable function value 3, and we're getting back variable of function. Oh, because he doesn't start with that. He's got spaces. No, we filter those out. All right, we're going to have to go look. Okay, this is the kind of thing I expect to fuss with. All right. I'm not in the right test, am I? Let's just run this test. What? Parser Swift. Oh dear. Okay, we're going to have to deal with this variable yet. So now we come into our top level grammar and it says, okay, variables, if you're just a simple variable not followed by an equals, then go be an expression. Or no, he says you're a simple variable not followed by an equals. That makes you a variable. All right, so it never gets down to our case. So let's get there. So up here, yeah, so a simple variable just gets parsed as a variable expression. Okay, I think we can take this out. Well, now it's going to break the defined cases. Well, I don't think we can take it out yet. I think... See, I'm trying to switch this thing out the middle is kind of the way I look at it. And it's a little weird that because of the way the grammars work, you know, we match the token, we're matching that token, and then we're looking for equals. But I really want to pull this piece out of the middle and do something else. So I think what I'm going to have to do, I'm going to make something that is expression or definitions. Well, maybe it's function call or definition. Okay, so I'm trying to introduce a new grammar rule that's going to make things work. So this rule is going to be function call or def, so you'll forgive me for abbreviating, it's going to be expressions, which is one or more expressions, and then an optional, I've been double quoting, equals and more expressions. And that is optional. Okay, so if you want a function call, you have a bunch of expressions followed by equals expression, and that gets you a function call. Okay, now I'm trying to pull variable in. I know it's like crazy, but it's the way it is. Okay, so to do this, we certainly call expressions. Okay, and then we're kind of in the middle here. If token equals equals, I'm kind of relocating this code. After you finish matching your expressions, if you've got an equal sign, well, let result equal expressions for now. Okay. If you have an equal sign, you skip the token, and then, well, one way we can do this, we say left-hand side is a pretty common abbreviation, and right-hand side. Okay, so you'll forgive me for those, I hope. All right. So now, and this thing, the definition, what does he want? He wants a name. Well, right now, expressions is going to come back as Wow, it comes back as function call. That's not so helpful. This is going to be something like left-hand side, right-hand side when we get it straightened out. But name, well, for now, if you just did variable equals some value on the right-hand side, I think you're kind of okay now. Oh boy. It's a single expression. Well, right now, this thing is going to return a function call, a named function call, as its expression. It's just not good enough, is it? Okay, let's not jump so far. So I'm going to make this thing be an expression, a one single expression. Okay, and I think at this point, if LHS is a variable, we can return it. Okay, so let's do LHS as variable. Not convertible. Well, I guess that's what I want to do for now. Okay. And this may not cover the cases, but we'll see. To expected argument type string. Oh boy. Okay, let's pull it out slowly. All right. Let name equal LHS as variable. And then we'll take name dot name. Well, let's call this variable. Okay. And I'm kind of forcing the cases. We're definitely going to have to generalize. This thing should return an expression. Okay. In our final case, we're going to return LHS. Even though it's not a left-hand side yet. All right. I think this should be equivalent. So what we're trying to get is if you call LHS with just a variable equals function, LHS should come back as a single entity because of this. It should be a variable. And so LHS comes back as a variable. We see an equal sign. We say, okay, skip over the equals, match the expression on the right, determine that this really is a variable, and return a definition. It's our simple definition that doesn't do enough. It's only name equals expression. If there is no equals, we just return that function call thing. The difference here is the right-hand side now is a function call object. And the test that looks for it is probably going to be surprised to find that. And maybe that's not the right type at this point. I don't know. We'll have to see. Run the tests. I think there will be some failing tests on the definition stuff. Oh, I didn't even call this thing, so nobody's going to be doing anything. Who are you? Oh, it's my... Don't need that. Okay, should be the same. Yeah. All right, so I think if you, instead of calling variable expression, you call function call or definitions. Let's try that first. Okay. So I'm trying to kind of rearrange variable expression to work in our new approach. And let's see if that does work. But I think somebody's going to be saying, like, named function call? What the heck is that? Okay, there's test function call. Who else? Only that. Well, let's make sure this still looks like we expect. Function. Oh, now we're getting there. Named function call variable function bracket 3 bracket is not equal to variable function bracket 3 bracket. Okay, what's your problem? Let's break. Now let's break right here. We'll run this one. Okay, let's print expected. Type. Oh, maybe our types aren't matching. Type generic. Name function. Expressions 1, value 3. Okay. It looks very similar. The type equals unknown. Get this in one view if I can. Not quite. Okay, R0, Elm expression equals the type equals unknown. Variable, it's a different name, but it's a generic type. Oh, named, no, named function. Okay. And a value with all those. Expression, the type value 3. That sure looks the same to me. We messed up something in EQ maybe. Okay, if the other thing is a named function call, this is expecting array to do the equality test. Let's make sure that's how you do that. Swift. Well, they got that. Two simple arrays. How it interprets that. Comparison based. Yeah. They do not conform to equatable. Oh, it calls equals on each one by default. Okay. Why our test passed the first time? Okay, let's find the Swift grammar thing for that. Collection types. Okay. Hopefully it points me to the underlying documentation for array. NS array. elements equal well, let's try that for starters. I'm a little puzzled why our equality test did not catch it, if that's really a problem. Continue. Nope. Now that's really odd, right? I mean, name function called variable function, element 3. And we got one that looks just like it, and I thought that was our test too. A variable. Let's make sure we got unique elements coming against each other. Haha. Okay. Name function called variable it is not equal to name function called variable it. That's what we wanted to find out. Name function call, oh, because these were equals. Triple equal says I need the same pointer. All right. At least our equality test should pass now. Yes. And I think our parser test passed. Whoops. I lost it. Oh, no, there it is. Function call. Okay, that's all that was going on there. Oh, wow. Okay, so commit this. Bare bones function calls. Parsing successful ones only. I know that's kind of all right. So that tells me, oh, there's a couple things going on. One is we need to see if there's other triple equals out there, I guess. That's the real starter point for me. Yes. Yeah. Okay, closure. Symbol table. Oh, yeah, the symbol table is probably special. That probably is literally the exact other piece of the other symbol table, because you're, yeah. Okay. We're assuming they're built from the same thing. So, okay, I just, basically a copy and paste error, right? I sort of used this for the structure and swapped in some names. So, yeah. Preaching it isn't enough. All right. This thing looks okay to me. Now, we still have a bit of a mess in parser, and I think we got about 12 minutes left by my clock, so let's see what we can do. Is anybody calling this now? I bet some tests are, and I bet those tests can't. Hey, That was weird. Variable expression, callers. It says it has one caller, but it doesn't. Let's look for it as a text, variable expression. Okay, we did get rid of this. I'll keep this part of the grammar. And I'll say old that. Just so we're knowing what to look at, I guess. Okay. Now, I guess my question would be, if I comment this, does it work? No, it doesn't. Because it doesn't handle definition. This expressions does not handle definitions. That's why we have it separately, because you don't want to allow expressions equals expressions equals expressions. You can't define things that way in Elm. I don't think. I'm pretty sure I tried that. X equals Y equals 3. Yeah. Y equals 3. X equals Y is fine. X equals Y equals 3. No. X equals Y equals 3 interior. No. Okay. So yeah, we can't do that. So we can't have expressions do expressions equals expressions, because it would then be covering both these cases. So this function here makes the decision: are you a function call, or do you have an equal sign in your definition? And if you're no equal sign, then you're just a function call with this stuff in it. I mean, we're still a little weird here. The RHS we're getting back, is expression. We don't handle expressions yet. So right now, if you just have an expression, which is X or Y or lambda X goes to X, or 3 or something, that gets parsed by expression, and it always comes back as expression. And if you're always passing in a variable for the first expression, then that's fine. All right. But we still have a lot of error cases to call. Okay, we created named function call. So let's capture some of this. Okay, so done. 2021-03-05. I don't know if I had nothing yesterday or I just didn't write it in, but story function call. We created named function call. Okay. Parse function calls. I guess we sort of do that. I mean, yeah. Excuse me. Error checking on name function call. How to handle multi-argument functions. Yeah, I mean, when you get to the semantics, we got some definite stuff going on. Function definition with arguments. All right, we still do single. I guess I put this up here. Single argument definition with only one expression, and single argument definition with multiple expressions. Excuse me. All right, so those we'll have to deal with. Now, what else is going on in parser? Well, let's make sure this stuff works. Did we get rid of everything we wanted to? What changes? Parser. Okay, we got rid of variable expression, which is dead code, and moved some comments around. Okay, so let's commit that. Refactor. parser.variable definition, did we call it? We called it variables, I guess. Okay. Good. All right. Now, I feel like this is still confusing. What I would like to do, I would like to, instead of calling this, I would like to call this. And I don't know if that will work or not. We definitely have some shortcuts we've done in here. Okay. Now our test cases don't have an equal sign, so they're really only going to... No, maybe that should be fine, I guess. It's only passing it through if it doesn't have an equal sign. Okay. Now I'm feeling good there, so let's see. I guess that's a refactor. Top level goes through function call or definition rather than directly to expressions. And I'm calling it a refactor partly, it's not, how do I say it? It's a refactor for the kind of data we have. It's not a refactoring for the possible data that we could have in the future with equal signs and multiple stuff and all that. But the way it is now, if you don't have an equal sign, it calls expressions like it always did, and everything's cool. All right. I don't know what the right thing to do for 5 minutes is here. Is there any little... Well, I'll tell you an easy one. I'm feeling like a float value could default its type to elm type.float, and integer could default to number, and it would simplify a lot of tests. So let's take a look at that thing. Let's do type equals elm type equals elm type.float. Okay. Now everybody should be okay. Oops. Whatever control Y does. Everybody should be okay with that. All right, now let's take a parser type. If I do this, is everybody still okay? All right, let's find our float values. All right, those are all good. Do a global search for float value. I will let it default. Actually, I don't mind calling it explicitly there. All right. Float value. Those are okay. These tests. I think the test is enough because it's going to pull the type out. So if it were wrong, it would know. Whoops. Somebody was complaining. I didn't see what it was fast enough. Type.float. Okay, and tuple test. All right, we'll do a build. Run our tests. Somebody had a complaint. There it is. Oh, integer value doesn't do that yet. type. Come on, Elm type dot number. All right. So I'm going to take a to-do, just a refactoring. Make type argument optional on integer value. So we can pick up there next time. All right. Next time is Tuesday, 1 to 3 p.m. And that's Eastern time. We'll pick up with this refactoring, and then we'll go ahead and push this function call thing the rest of the way. Get something working there. Get the tests in place for the error conditions and all that stuff. So it'll still be a bit of work, but we're making progress. The parsing seemed to be okay. It wasn't. I was worried there'd be some ambiguity that hurt us, but right now I think the ambiguity is kind of buried in like we have semantics to apply. So anyway, I hope I see you in the future. Thanks for joining me today, and have a good weekend. Bye-bye.